Okay, so we have this Sub-Zero UC-15 ice machine, UC-15, and the story is that I went on a service call last week and diagnosed this as it was extremely dirty, hadn't been cleaned since it was new, it was filled with oxidation and calcium. And I took all the parts apart, I brought it into the shop, I cleaned everything up. Even the pump wouldn't work, there was so much garbage in it. I got everything cleaned and working. I brought it back to the customer's house, plugged it in, the water was spraying, everything was good. But they called me back and said it wasn't making ice. So I'm thinking that maybe the hot gas valve or possibly a freon leak. So we're going to get it up on the bench and then we're going to diagnose it. And if you want, you can follow along. Okay, so I got it up on the bench. As you can see, I rigged up a drain hose that's going out my door. Fortunately, on the East Coast, we are going to have a warm weekend, so I was able to open up my water lines. Now, I'm going to turn this on. Turn on the water. So let this run. That reservoir, we'll let it fill up. Actually, you can probably still see some of the residue in there. It was really bad. You can see some of it up here still. You may have to clean it again. But yeah, so let's let it run, fill up with water. We'll take the back cover off and check it out and check the freon levels, and also I think it's the hot gas valve, but I could be wrong, don't really know yet. So let's let it run for a while and I'll come back to you. Okay, my friends, this machine's been running for about an hour now, and it's not making cubes. And the evaporator plate is cool, but it's not freezing, it's not tacky. Alright, so you can see all this green stuff. The whole machine was covered with this calcium. So it does need another cleaning. However, we have to figure out what's wrong with it first. So I'm going to the next thing I'm going to do is tap into the sealed system, and let's see where the process port is. I'm going to take this piece off here. The hot gas valve is right there. Just in case. The condenser is not warm, so I'm going to suspect sealed system problems. So we'll remove this rear cover here, get access into there. I got to find out where the process port is. Here's the discharge line right here. So here's the suction line covered in all this insulation. There should be a process line on here somewhere. We'll find it and then we'll tap into the system. It's either going to be a leak or it's going to be the hot gas valve could be stuck open. All right, now we know what we have to do. I'll be back. Okay, this machine has been running overnight and it has not made any ice. It's not even cold inside. Feels a little warm. So we will take this apart and we will get into the sealed system and find out what the pressure is and see where we're at, because it's going to either be the hot gas defrost valve, which is probably stuck open because it's not refrigerating at all, as I showed you before with the evaporator not frosting up at all. Okay, let me get in here and see where the process port is. Alright, let me find that and we'll get back. Okay, so there is a process port or line right here, one high side, one low side. So I'll get a line tap valve on there and check the pressure, and then we'll put drain the freon out, we'll put a process port on there, and then we'll go from there. Stand by. I'm going to take the door off. Make it easier to work on. Take the front cover off. Now, let's see, need a 5/16. Okay. Okay, now here are your two lines. One is a discharge high side, one's a low side. This one here is attached to the hot gas line up there, so that's the high side. So this one, it does go all the way to the back. Oh, so it's actually this line right here. Didn't even notice that. I could just take that whole thing out and put a process port right in there. But maybe it's better to have the process port here in the front. So I'm going to put a line tap valve on here, drain the gas out. Now, this is just a temporary procedure here. We're just going to use this. I mean, it's not recommended to leave line tap valves on all the time. Supposedly they leak. I really, in the 57 years that I've been doing this, very rarely have seen these line tap valves leak when they're on the low side. Definitely not put them off on the high side. I've seen people do that, but I would not recommend it. But on the low side, yeah, I don't see why not. And everybody has their, I mean, the factory doesn't recommend using these to stay on. They always recommend putting a sweat on process port. And there are some tools out there, supposedly, that allow you to just, it looks like a pair of pliers. Actually, I think I have one. I'll show you what they look like. Every time I use them, I think they work well on larger lines, but for a 1/4 inch line, when you put this tool on there, it always leaks. For me, if I'm doing something wrong, let me see if I have one I can show you. Yeah, there it is, right here. There's another one here. I took the piece out, but this is what it looks like. Supposedly it taps into the line, and that little piece of rubber there keeps it from leaking out. I've never been successful using that thing. I don't recommend it. I think that would work well on maybe 3/8 1/2 inch line, because once you squeeze that thing, you squash the tubing. Okay, now we're going to pierce the line. We're going to get our recovery tank. Put it right here. Okay. we got Freon in there. That's a good sign. I don't know how much. Let's see, we got about 1, 2, 3, around 4 ounces. I don't think this machine takes 5.6 ounces. I don't know, that's leading me to believe that maybe there's a hot gas defrost problem. Okay, so I'm going to remove this line tap valve, but first let me get this out of the way. Okay, where are you, little line? There you go. There's a little piercing hole there. So I'm going to cut this right here. All right, what do we got here? Actually, I'm going to use one of these. Okay, so let's put this Schrader valve in here. And instructions here tell you right here not to use manifold gauges and hoses to check the pressure. To use a short hose or a process line to check the pressure. Why? I don't know. I guess there's a reason for that. So now what we need to do, I'm going to take here's what we got on the Freon. Now I've got these graduation marks right here on my R22 scale because I don't have an R134A charging column, and you can't buy these things anymore. But this is 2 ounce, every half an inch is an ounce. So this is 2 inch, 2 ounces, 3 ounces, 4 ounces. It's about 5 ounces, and it takes 5.6 ounces of Freon. So you figured there was some in the hose. So I don't think this is a problem with the Freon level. It's looking more like a hot gas valve. So I'm just going to shoot some 134A into the system. Make sure that we're going to have to pull a vacuum on it, but I want to see if we have a leak here. So why don't we turn the machine on, suck in this Freon, because we're going to have to put a new filter dryer on here so we can do an evacuation. And at that time, I just want to see what's going on. I'll let that go in, and then we'll see what's happening. Okay. I only put 2 ounces of Freon in there, and I'm running a back pressure around 50 pounds. That's telling me that we have a problem in the sealed system. So what I'm going to do now is I'm going to put another process port on the high side so I can pump the compressor down and see if the compressor is bad. And if the compressor is good, then what we're going to do is take the hot gas valve out. I'll see if I have one in stock and we can change that. Okay, this is how I check a compressor. It's called a pump down. You open up the high side. I can hear the compressor running. There's nothing coming out. All the Freon I recovered. We only have about 5 inches of vacuum here, and that's telling me that this compressor is not pulling down. It's probably got a bad valve. Going to let it run a little while longer, but normally if you can't pull down more than a 26-inch vacuum, then you probably have a bad valve in your compressor. That's going to give you a higher back pressure. And I told you before, I only put 2 ounces of gas in here and I was getting 50 pounds back pressure. Now it's beginning to make sense to me. But the way I check it is, in most cases you're going to be able to get at least maybe 29-inch vacuum on a really good compressor. If you get less than 26, I would be very skeptical about if that compressor is any good or not. But what I normally do is I'll pull it down as far as it will go, and then I shut off the machine, disconnect my hose, close off the high side. If the pressure comes right back up, you got a bad reed valve in there, and so it's not holding the vacuum. What I was taught in school was that it has to hold for 3 minutes to show that the valves are sealing properly. Anyway, this looks like we have a bad compressor in here. That's a surprise to me because I haven't run into a bad compressor on one of these machines in a really long time. But the history of this machine, it was extremely clogged up and dirty. There's still a lot of oxidation in there, even after I took all the parts out and cleaned them. So to change the compressor on this machine, I have to pull the shell off. That's not easy to do. It's a lot of work. I'm going to take it off the bench and put it down on the ground. But in some of my previous videos, I've showed how to do that. But that's the only way you're going to be able to get in there to change that compressor. And I just happen to have a UC-15 compressor right here that I pulled out of a machine a while ago and saved it just in case. Now, the compressor, the customer, if I tell the customer they need a new compressor and they want to go for it, it's a lot cheaper than buying a new one. However, they may not want to. So just for the sake of making this video, let's replace the compressor to see where we're at, just so that you can see how to do it. And that's what we'll do next. I'm going to let it run a little while longer. It's not getting any better. If I shut the machine off, let's see if it holds a vacuum. No, it's not. See, it's coming right back up. It's got a bad valve in there. All right, that's the diagnosis. Bad compressor. Okay, let's start to prepare to remove this compressor. Now we've already taken the Freon out, so we don't have to do that. But we do have to disconnect electrical leads, especially, you know, I mentioned it on one of my previous videos working on Vikings. Vikings are notorious for getting cuts. Okay. Now we're going to disconnect this. Okay. Make sure you take the plug out. Now, according to Sub-Zero instructions, they're saying remove the capacitor and the relay, disconnect the wires, and pull out the little clips that are holding the compressor down, front and rear. We can get the other ones to the front and then pull the compressor out. We have to, of course, cut the lines, and they're recommending not to unsweat them because it would introduce moisture into the system. Well, you know, we'll pull a vacuum on it and get the moisture out. So what's the big deal? Okay, so move the valve over out of the way so I can get to these pins, these little clips that hold the compressor. And that's one. Okay, now let's see if we can lift this thing out. Okay, I got this rear plate out of the way by disconnecting the ground wire and the feed into the water manifold. That gives me more room to work here. And also, I took out the manifold and the water valve to give me some room to work in here. So now you can see, you can see here is the discharge line, here's the suction line. You have to take also these little spacers, I don't know what they call these fittings here, that go over these supports where the clips go. The other one's right here. It's a little tight. I mean, we could take the shell off, but I think this might work out okay. So now I'm going to unsweat or cut this discharge line because it's attached to the hot gas valve, which is screwed down onto the cabinet there, and then we'll go to the next step. Okay, so I am going to unsweat the discharge line. I'm going to switch my turbo torch from a number 5 to a number 3 tip. And then I'm going to put some kind of a shield. This is the replacement compressor. As you can see, I crimped all the lines when I took this out to keep moisture from getting in there. Put that there and get my light. Put that there so we don't burn the cabinet. I'm worried about that piece of styrofoam there. If we can get the torch facing that way. Well, let's see how this is going to pan out. This number 3 tip is a really small flame. Yeah, we can do that. Alright, so let's do that. Get a needle nose here so we can pull that off. Turn on our tank. Be careful where you point the torch. Okay, that's out. No damage. Okay, now let's move to the rear and see if we can get this out. Alright, so I used a pair of pliers to lift this up, and I lift up the front. Now I can take this other ground wire off here. Okay, get that out of the way. Gloves, gloves, gloves. Let's see what's going on with this hot gas valve here. Okay, she's out. This is a EMI 65 HNR. It's 650 BTUs. I'm going to unsweat this, and then I'm going to unsweat the suction line and remove that compressor. Okay, we're going to separate this insulation here, get it out of the way so we don't melt it. They got an elbow on there. Get that out of the way. I just unsweat the process tube. And be careful, you don't want to kink at this. See, I got a kink right there. So we're going to have to fix that. Alright, so the other compressor has the elbow in it. So maybe what we'll do is we'll cut this right there so we don't have to risk putting a kink in there. There it is. That's the old compressor. That's almost 2 inches. So we're going to go right there. Okay. Prepare this. Kansas City's playing the Bengals. Tonight, the Eagles are playing the 49ers. And we're going to check those games out.
my swage block and 5/16 5/16, it's a quarter. No, this is 5/16. Okay. This thing is fully seated, you'll hear a different sound. Here, a different sound. That means it's all the way in. Done. Okay, now we're going to clean that out. Flux. Okay. Discharge line. Get that out of the way. Okay, so we disconnected that. We soldered that. Get a wet rag. And next we're going to do we're going to direct it in. Of course, we have to check for leaks before we put this back together, so it's all part of the plan. Looks like a good leak. I mean, a good seal anyway. All right, now gloves. Okay, I really don't want to put this back on yet until we check for leaks. Here's the
Now, we want to check for leaks before we put this compressor in here, but we have to seal off the discharge line. Otherwise, it ain't gonna work. Okay, so I'm gonna put some nitrogen in here. Let me get my gauges here. You know, a long time ago, I remember reading an article about a guy who pressurized the refrigeration system with oxygen instead of nitrogen, and he blew himself up and the house included. It's amazing. It was a story, and I'm not sure where it was. I think it was the Appliance Service News. It's crazy, man. That's crazy. I would never put anything in a system like that. Okay. Pressurize the high side. Got 175 pounds pressure in there. Okay, now I'm going to unsweat that process port and get this compressor back in.
Please charge it in time.
Okay, I had a problem with my video camera glasses here. They ran out of juice, so I couldn't show you how I put the filter dryer on. But the hardest part of getting this thing back together was getting the compressor on top of those studs that stick up to hold it in place. But I got all the clips in. I changed the capacitor. I used the older capacitor from the other unit, the one I didn't burn. And so now I got the door back on. It's all back together. We just have to put the Freon in there. So I'm going to load up the charging column with 5.6 ounces of 134A. Looks like I've got 1, 2, 3, just a little bit over 4 ounces in there. So I'm going to put some more 134A in there, and we're going to charge it up and see if our diagnosis was correct. Okay, so the machine is running now. We got the high side line open to draw out all the air. We're down to about a 29-inch vacuum. That's a major improvement over the old compressor. So now the last thing to do is to put 5.6 ounces of refrigerant R134 in here. So I have to put some more in there. So let's get that ready and I'll be back. Okay, it's been running in a vacuum for a while now. I put the Freon refrigerant in the charging column. I put a little extra to compensate for the hose. So let's go. Let's do it. Okay, it's been running now for about an hour. It's running right now at 5 pounds back. The normal pressure reading for this machine is 0 to 18 pounds. Usually when it comes off a harvest cycle, it's going to be closer to 18 pounds. And then by the time it goes into harvest cycle, it'll be probably near 0. So, there you go. We're making ice. You can see that. So I'm going to let it run and then button up the job. So we were right on the diagnosis. It was the compressor, because we weren't getting anything before. So we'll let this thing run overnight. We'll check it in the morning, and I'll get back to you on it. Thanks for watching.